We need to go ahead and review parallel and perpendicular lines for this lesson. So remember that parallel lines are two lines that have the exact same slope. So that one's probably not as good. Let's see. Alright, so remember on a graph they'll never touch. So since they'll never touch, they'll have like equal space between them the entire time. And since they have the same slope, notice they go the same direction from left to right. They both go down. And they have the same level of steepness. So if these were hills, for instance, this hill would be just as steep as this hill. One is just moved up or down from the other. So parallel lines could go any direction. They can be horizontal, but that just means the other one has to be horizontal as well. Or they can be vertical. That just means the other one has to be vertical as well. That way they maintain that equal space between them. So parallel lines have the same slope. So that's what we have to remember there. Same slope. So that means in their equation, let's say this one had the equation y equals 1/2 x plus 1. I'm just making it up. So let's say this one had the equation of y equals, well, since they have to have the same slope, that means that this one also has to have 1/2 x. And then it just has a different y-intercept. So maybe the y-intercept is plus 5 or something. So notice the slopes are the same. Alright. Now, the difference is with perpendicular lines. Perpendicular lines just have to form, just remember what perpendicular means. They have to form, oof, that one's bad. Okay, let's try that again. They have to form a right angle. So perpendicular lines form a right angle if, remember, a vertical line has the equation x equals a number. Well, a horizontal line has the equation y equals a number. So see how they're kind of like opposite in a sense? So really what they are, if we actually, they don't have to go straight up and down or left and right, so they don't have to be horizontal and vertical. They could be slanted, but as long as the other one forms that right angle with it, they're perpendicular. So the slopes aren't necessarily opposite, they're opposite and reciprocals. So what I mean by that, let's say that this had a slope of, let's say the m for this one was negative, because notice it's going down from left to right, so it'd have to be negative. Let's say 1/2. Well then, this one, notice it'd be a positive slope, would be a positive 2. So notice the signs, oh, my hand wrote that over there, it looks like. So notice the signs are opposite, so one's positive, one's negative. And then the number itself, just the number part, those are reciprocals. What I mean by reciprocals is like, well, if we flipped over that fraction, it would become 2/1. Well, what is 2/1 simplify to? It simplifies to 2. So they're reciprocals of each other. Alright? So I'll go ahead and just put an example that I'll leave on here. Just have to get rid of this whole graph like I did the other one. But if we have, let's see, grid, and I'm going to leave two perpendicular lines on here. So remember, they have to form a right angle right there. And you don't have to see the right angle mark if you know the equations of the line. So once again, let's say that was y equals, so let's say it had that slope of 2x, and looks like the y-intercept's in the negative, so like -7 or something. And then let's say this line had a equation of y equals -1/2 x plus 3. Oops. Since it looks like the y-intercept would be in the positives. So basically notice the slopes, they're opposite sign, one's positive, one's negative, doesn't matter which is which. And then the numbers would be like the opposite, not opposite, but one would be flipped of the other, for instance. So we just call that simply opposite, well, I'm going to put it up there by the graph, opposite reciprocal slopes. So opposite reciprocal slopes. That's the slope. Alright. So that's how we know if two lines are perpendicular. So let's say I gave you two equations, y equals 3x minus 1 and y equals 1/3 x plus 2. And I asked you, are they parallel? Are they perpendicular? So, what are you looking for? You're looking for either same slope, and when I mean same, I mean exactly the same. Same number, same sign. And notice we don't have the same slope, so we know it's not parallel. The other option is opposite reciprocal. And it can't be one or the other. It can't be opposite sign, but not the reciprocal. Or it can't be the same sign and then the reciprocal. It has to be both of these two things. So opposite, remember, means opposite sign. Well, look at the signs of this. This is a positive 1/3, and the other one is a positive 3. Well, therefore, it doesn't even satisfy the first part of perpendicular, so it's not even perpendicular. So these equations would be neither. They're not parallel, they're not perpendicular. So let's say I had y equals 1/5 x plus 6 and y equals 1/5 x minus 3. Well, notice the requirement for parallel, if you remember, parallel is just same slope. So same slope. And if you look, it doesn't matter about anything else. All that matters is about that slope. The slopes are the same, therefore these two are parallel. Oof, right terribly. But yeah, so therefore they're parallel. Alright, if I did another example, y equals 2/5 x plus 7, and I said write an equation of a line perpendicular to this line. So basically, we know that the slopes have to be opposite reciprocal. So remember, opposite means opposite sign, so I know the other line would have to have a negative since that one's positive. And then remember, reciprocal just means basically flip over the fraction. So 5/2. And then I just have to have a different y-intercept, or it could be the same if it's perpendicular, just not if it's parallel. But I mean, I could just make it anything. As long as the slopes are opposite reciprocal, it doesn't matter what the b is. So now let's actually do some problems that you'll have to do. So notice it says write the slope-intercept form of an equation of a line described. So, let me change my thickness. Alright, so we need to write the equation of a line through this coordinate. So kind of like yesterday, we were given a coordinate, so we have an x and y value we can use. And we also are trying to draw or write the equation of a line that passes through this point but parallel to this line. So basically the situation we have here, we have a graph. We have some equation of a line. This y equals 3x plus 4. So basically we have some line already, and then we have some point, -1, -1. So we have some other point on the graph, and they want us to find the equation of the line that is parallel to the line they gave us, but passes through that -1, -1 point. So they want to know, what is that equation? Y equals what? What is the equation that will create that line? So that's what we're looking for. Alright, so how do we do that? So, first things first, we know we want the equation of the line parallel to this equation. Well, what do we know then? We know they have to have the same slope. So we know, probably shouldn't circle all that, let's just circle the 3, just the slope. So we know that the m of that other equation, or that other line, is going to be 3. Because we know they have to have the same slope since it's parallel. So we know the m is 3, and just like yesterday, we need to find the b. We need to use the x and the y that they gave us to find the b. So now let's go ahead and do what we did yesterday. So y equals mx plus b. Well, we know the m is 3, and we know we can use an x value. Well, the x value there is -1. I'm going to bring down my plus b, because remember we're getting b by itself. And we know we have a y value we can use of -1. So now, just like yesterday, we can go ahead and simplify this. So this becomes -3. I'm going to bring down my plus b, my equal sign, and my -1. And I know now to get, this is my equation, so to get b by itself, I need to add 3 to both sides. And that leaves me with b is equal to 2. So I know my b value is 2. So now, since b equals 2, we know b now. Now I can write the equation, y equals 3x plus 2. So now I know the equation that'll go with that line that'll be parallel to the line they gave us and passing through the point -1, -1. Alright, so just to do another one, this one, once again, if we just think about what we have an equation of a line. We have some equation of a line. We want to write the equation of the second line that will be parallel to this equation, but passing through that point. So if we had that point there, basically we're trying to find the equation of the line that'll pass through that point and that'll be parallel to that other line. So remember, to do that, we know since it's parallel, they have to have the same slope. Therefore, I need to go ahead and take that b out that equation, because that's what I'm going to use to find the other line. So I know my m is equal to 5/7, and I'm looking for my b value. So y equals mx plus b, and we're going to use that m is 5/7, and we're going to replace x with our x value from the coordinate, and we're going to bring down b because we don't know the b of that second line. We don't need the b of the first line, we're trying to find the b of that line. And then our y value is 3. Alright, so now we're going to go and do a little bit of math here. So that is 20/7, or 20/7. Remember, like I said yesterday, to do a whole number times a fraction, you just multiply the numerator times the whole number. And you could simplify if it does. Something tells me that one doesn't. Alright, so I'm just bringing everything down. And now, to get b by itself, I need to subtract that fraction of 20/7 on both sides. And I know I'm running out of room there, but when you subtract, you get b equals 1/7. So you could check that in the calculator if you like. So now we know the b value is 1/7. 1/7, and now I know my equation is y equals 5/7 x plus 1/7, and that is my final answer. So to figure out a line parallel to another line passing through a coordinate, it's kind of straightforward, because it's basically like they gave you the slope, because they gave you that equation with the slope in it that you're going to need. The only other variation of this, I want to draw your attention to number 4. So notice it's passing through a point again, but it's parallel to this line, y equals -4. And if you remember from Unit 1, and then I mentioned it yesterday as well, the line y equals -4 is a line that goes through -4 on the y-axis, and it goes straight through, so it has a slope of 0. So now when you're trying to think, okay, what does a line parallel to that look like? Well, a line parallel to that would have to go the same direction, same slope. So remember, if it has the same slope as this, then it's somewhere else on this graph that goes like this. I mean, it could be there, it could be here, it could be here. So all those lines are parallel to that line. So we know it also is going to look like y equals a number. Well, what number? Well, look at what point it passes through. Look at the fact that it passes through the point 3, negative 1. Well, no matter what you do, if you really look at this, over positive 3 and down 1, it's going to be here. It's going to pass through the y value that the coordinate has. So the coordinate has a y value of negative 1. That means the equation has to be y equals the y value of the coordinate, negative 1. Because remember, the equation is just y equals a number. Well, what number? The y value of the coordinate. So those are pretty quick to do if you just recognize, okay, well, if it's y equals negative 4, that means the other one has to be y equals whatever the y value is. If it was an equation that said x equals 3, well, I know the equation parallel to it will be x equals whatever number is in the x spot. Oh, that is 3. I should get a different example. But yeah, so when you come across the x equals a number, y equals a number, and it's parallel, you know the equation is going to be pretty much the same, just the x or the y value of the vertex. I mean, of the coordinate. Okay, so I'm going to go ahead and erase this because we don't need this. It has nothing to do with the problem. And we're going to go ahead and do some perpendicular ones just so we get some of that practice. So if you look at perpendicular starts at number 7 through 12, we'll just go ahead and do 7, 8, and 10. Just to do 3 problems together, and you guys will do 3 on your own. Okay, so same as before, we need to look at the fact that we're doing, are we finding an equation of a line that's going through 4, 1, perpendicular to this line. So remember, that means that perpendicular, we're going to need the opposite reciprocal slope. So basically, the slope of this line now is negative 2. So do the opposite sign. So the slope for the line we need is going to be opposite sign. So if that's a negative, we know our slope is going to be positive. And if it's going to be the reciprocal of negative 2, well, think about 2, just the number part is 2. Think of it as a fraction, that's 2 over 1. But the reciprocal means, remember, that we have to flip it over. So it's really positive 1 over 2 for the slope that we're going to use. Alright, so now we're going to go ahead and use the x and the y out that coordinate. And y equals mx plus b. And we know now the m that we're going to need is 1/2. And the x that we can replace x with is 4. And we're going to bring down our plus b. And then our y value is 1. So now when we solve our simplify, we get 2 there. And we're just bringing everything down, and we're going to go ahead and subtract 2 from both sides. So doing that gives us b equals negative 1. And since b is equal to negative 1, our equation's y equals positive 1/2 x minus 1. So remember, we just found the equation of a line that's perpendicular. So it's perpendicular to this other line. So if that line looks like that on a graph, for instance, then the equation we just found is perpendicular to that. So it'd be something like that. That forms a right angle. So this is the one we just found. Something that looks like that. Alright, so that's just a quick sketch of what it would somewhat look like. So now let's go ahead and look at number 8. Alright, so once again, it's perpendicular. We want the equation perpendicular to this other equation. So we need to steal the slope out of there, but remember, we don't want it exactly like that because it's going to have the opposite reciprocal slope. So since this 3/5 is positive, we know our slope is going to be negative. And remember, the reciprocal means to flip it over. Since that 3/5 is already a fraction, if I flipped it over, it would become 5/3. So our slope is going to be negative 5/3. Now we're looking for that b value. So now we can use y equals mx plus b. And our slope we're going to use is negative 5/3. We're going to use the x value they give us in that coordinate. And we're just going to bring down plus b. We're going to use the y value they gave us in that coordinate. And now we can go ahead and simplify. So if you multiply that together, you'll see it actually just turns into 5. Alright, and I'm just bringing everything down. And then remember the last step, I'm going to get rid of the 5 so I can get b by itself. I'm running out of room, but it looks like b is going to equal negative 4. So now I can go ahead and write my equation, because now I know b is negative 4. And my equation would then be y equals mx, well, negative 5/3 x plus b. Since b is negative 4, I'm going to put minus 4. And there's my final answer. So the last one I'll do is number 10. Number 10, we're writing the equation of a line that's perpendicular to y equals negative 1. So here's a case where it's y equal to a number. But notice, y equal to negative 1, I'm just drawing a quick sketch. You guys don't have to draw these, I'm just trying to give you a visual of what we're doing here. So y equals negative 1 would be somewhere down here. So a line perpendicular to that now, notice it's not going to go the same slope because that'll be parallel. A line perpendicular to that would go vertically. So basically, remember that these equations that are vertical are x equal to a number. So here, my answer would be x equal to, well, whatever the x value is. The x value is 2. So that's my equation of a line that goes through to negative 3 and perpendicular to y equals negative 1. Alright, so you guys will finish up 3 for parallel. You'll finish up these 3, 3, 5, 7, and then you'll also do the remaining 3 for perpendicular. Alright, just text me if you have any questions.